In today's video, we are going to derive Prism formula. Prism formula given by mu equals to sine of a plus dm upon 2 divided by sine of a by 2. Consider prism ABC, and now let us consider two phases of the prism, that is refracting phase AB of the prism and the second refracting phase of the prism, that is AC. So AB and AC are refracting phases of this prism. Now let us see how incident ray travels through the prism and how it gets refracted. It is incident ray of light traveling through the prism and refracted ray through the prism. So this diagram showing how the incident ray travels through the prism and how they get deviated after refraction through the prism. Consider principal section of the prism, that is A, B, C. This is the principal section of the prism. Three rays here. One is the incident ray, second one refracted ray, and the third one emergent ray. Let us draw the normals at the point of incident and at the point of emergent. Now what you do, you extend the incident ray and extend the incident ray in the forward direction and extend the emergent ray in backward direction like this. So there is an angle between incident ray and emergent ray. Call this angle as delta. Let us call angle of incident as I, and this one is the angle of emergent. Now let us label it. This point is a P. Call this point as a Q. Call this point as a M, and this point as a N, and this point as a R. There is a one quadrilateral AQNR. In this quadrilateral, angle AQN is 90 degrees and angle ARN is 90 degree. Therefore, angle A plus angle QNR equals to 180 degrees. Call it equation 1. Let R1 be the angle of refraction at the phase AB and angle of incident at the phase AC equals to R2. Therefore, in triangle QNR, R1 plus R2 plus angle QNR equals to 180 degrees. Call it equation number 2. Since RHS value of equation 1 and 2 equals to 180 degrees, therefore comparing left side part of equation 1 and 2, therefore we get R1 plus R2 plus angle QNR equals to angle A plus angle QNR. Cancelling angle QNR both sides, we get R1 plus R2 equals to A. Call it equation number 3. Now consider triangle QMR. So triangle QMR. This angle Q equals to I minus R1 and angle R equals to E minus R2, and this angle at M is angle of deviation. Now sum of angle Q plus angle R equals to delta. What is angle Q? I minus R1. What is angle R? That is E minus R2 equals to delta. Therefore, I plus E minus R1 plus R2 equals to delta. Call it equation number 4. From equation 3, R1 plus R2 equals to A. Therefore, equation 4 becomes I plus E minus, in place of R1 plus R2 we can write A equals to delta. Therefore, I plus E minus A equals to delta. Call it equation number 5. Now suppose we increase the angle of incident, then the angle of deviation will decrease. As we keep on increasing the angle of incident, the angle of deviation will keep on decreasing and will attain the smallest value, will attain the minimum value. So that minimum value is called angle of minimum deviation. This angle of minimum deviation is denoted by dm, capital D and suffix small m, at delta D equals to minimum deviation, angle of minimum deviation. Then the condition is I equals to E and R1 equals to R2. I repeat once again, when ray of light suffers minimum deviation, then angle of incident equals to angle of emergent and R1 equals to R2. So at angle of minimum deviation R1 equals to R2, let R1 equals to R2 equals to R. Therefore, R plus R equals to A. Therefore, 2R equals to A. Therefore, angle of refraction R equals to A upon 2. Call it 6. Similarly, at angle of minimum deviation I equals to E. Therefore, in place of E I can write I minus A, and in place of delta I can write dm. Therefore, 2I equals to A plus dm implies I equals to A plus dm upon 2. Call it equation number 7. Let mu equals to refractive index of material of prism mu equals to sin I upon sin R as per as the Snell's law. Therefore, mu equals to, from equation number 6 and 7, mu equals to sin of A plus dm upon 2 divided by sin of R. R is nothing but A upon 2. This expression nothing but called Prism formula. Hence we derived Prism formula.